Hello everyone and welcome to my channel. I'm Jaren. Today we're going to walk through LeetCode Problem 189, Rotate Array. This question is a natural follow-up to previous problems involving arrays or string manipulation. But what makes this one special is that it adds an extra requirement. It asks us to solve the problem using in-place operations. This tests how well we understand space complexity. Ready? Let's get started. The problem requires us to rotate an array of integers to the right by k steps. For example, given the array nums is 1, 2, 3, 4, 5, 6, 7, we should rotate all the elements 3 steps to the right, turning nums into 5, 6, 7, 1, 2, 3, 4. And we have to do this in place. So what does in place mean? It means we cannot use extra memory proportional to the array size n. In other words, we are only allowed to use a constant amount of additional memory. That means the space complexity must be O to 1. To meet this requirement, an intuitive solution is to move one element at a time. To rotate elements to the right, we can remove the last element and insert it at the beginning of the array. During this process, we use just one temporary variable to store the last element, satisfying the in-place condition. We repeat this k times until the entire array is rotated. Let's look at the code. First, we calculate the length of the array. Next, to handle cases where k is greater than the array length n, we take k modulo n. Then we loop k times. In each iteration, we store the last element temporarily. Then, starting from the rightmost element at index n-1, we move each element one position to the right. Finally, we insert the last stored element at the beginning of the array. Now let's look at the optimized solution. There's a clever trick using reversal to solve this problem. We can reverse the array in parts to achieve the rotation. The idea is to use variable swapping to reverse the array. First, we reverse the entire array. Then, we reverse the first k elements. Lastly, we reverse the remaining n-k elements. Just like that, the array is rotated in place. Now let's walk through the code for the optimized solution. As before, we start by calculating the length of the array. And again, if k is greater than n, we take k modulo n. Here, we define a helper function called reverse. It takes two arguments, start and end. These represent the start and end indices of the subarray to be reversed. While start is less than end, we swap the elements at the start and end indices. Then we increment start, moving it to the right, and we decrement end, moving it to the left. When the loop finishes, the subarray has been reversed. Using this reverse function, we first reverse the entire array. Then we reverse the first k elements, and finally we reverse the remaining n-k elements. Now let's compare the time and space complexity of these approaches. Both methods meet the requirement of in-place operation, so their space complexity is O1. For the brute force method, we move the last element to the front k times. Each time we do this, we shift the other n elements one step to the right. That means each rotation takes On time. So the total time complexity is OKN. On the other hand, the optimized solution performs three reversals. The first reversal of the entire array takes On, the second reversal of the first k elements takes OK, and the third reversal of the remaining n-k elements takes On-k. Adding them together, we get On plus k plus n-k, which simplifies to O2n. And since we drop constants in big O notation, the time complexity is On. During interviews, interviewers usually expect candidates to come up with the optimized solution. By comparing the brute force and the reversal methods, you'll see clearly why the reversal method is preferred. This problem might look simple, but it's a great example of how to improve algorithmic efficiency, and it helps you explain your reasoning in a clear and structured way. If you enjoyed this video, please give it a thumbs up, subscribe, and ring the notification bell. I'll see you in the next video.